Hello, my name is Nurul Intan Hafiza binti Muhammad Tahir, 07 DKA18F 1071. I am from DKA5B. Today, we will present about our case study, which I will present is about the study plan location and also question 1. Study of location plan. So, figure 1 shows the plan of study location. The drain options that we have is alternative 1, alternative 2, and the overland. The measurements for alternative 1 is 4,549.22 meter. For alternative 2, it is 2,923.79 meter. And lastly, overland. The measurement is 176.85 meter. Next, figure 2 shows the overland and figure 3 shows outlet for alternative 1 and alternative 2. Next is figure 4 and figure 5 shows one of the group member was taking measurement of the main drain. And lastly, figure 6 shows the main drain. Now for question 1. The area of study location is 30.611597 hectares. The selected area study shown in the figure 1 as attached within this document. The area of study location is at Kepayan, Kota Kinabalu, Sabah. The location have 30.6 hectares, which the area consists of a few residential buildings and a few business shops. The main drain is divided into 2 routes. It was observed that the drains were in good condition. The main sizes from 700mm times 600mm to 700mm times 655mm. Next is the selected study location is a residential area that consists of 3 housing areas, which are Taman Fortuna, Taman Mesra, and Taman Land Breeze. Next is Taman Fortuna is a leasehold landed housing estate located in Kepayan, Kota Kinabalu. The build-up available at this project is 3,500 square feet. Taman Mesra is a leasehold mixed housing located in Kepayan, Kota Kinabalu. Taman Land Breeze, also known as Taman Land Breeze, is a leasehold mixed housing estate located in Kepayan, Kota Kinabalu. The build-up available at this project is 1,400 square feet to 1,524 square feet for houses and 3,400 square feet for shop offices. The type of houses are terraced, bungalow, and semi-detached. Other neighboring projects around are Austral Park, Luyang Perdana, Mandarin Park, Taman Fosang, Taman Kinamount, Taman Kinanti, Taman Land Breeze, Taman Minggeria, Taman Serigaya, and Taman Seri Menanti.
Assalamualaikum sir, I'm Nur Hamiza binti Tiga. Will present about question 2, calculation to determine peak flow for alternative 1. The upper of page of question 2, we stitch out the specification and picture about alternative 1 measurement and alternative 1's overland measurement. First, case study specification. Case study location is in area Taman Fortuna, Taman Mesra, and Taman Land Breeze at Kepayan, Kota Kinabalu, Sabah. There was residential area. Total area is 300,515.97 meters square, same about 30.61 hectares. Total distances is 2.60 kilometers. Type of drainage is minor. Slope 0.5%. Length of alternative 1 4,050 meters. Length of overland flow for alternative 1 LO 176.85 meters. First, design ARI using table 4.1. Okay, it's report from our case study type. There was residential and medium density, and from the table we get our minor drainage system equal 5 years ARI and major drainage system equal 100 years ARI. Next, estimate time of concentration TC using design chart 14.1, and from the table, like in this design chart, we using the red line. From the design chart, LO 177 meters and S 0.5%, assume paved surface, and we get TO equal 11 minutes. Then average velocity in open drainage should be assumed using Manning's equation. Assume V equal 1.0 m per S. The formula TD equal LD divide V, and we enter our value. 4050 divide 1.0 and we get 67.5 minutes. Therefore, to get TC, the formula is TO plus TD, and 11 plus 67.5 equals 78.5 minutes. After that, determine average rainfall intensity. Refer from table 13.A1. This was refer our location to in Kota Kinabalu, Sabah, 5 years ARI. A value equal 5.6093, B value negative 0.5.1034, C value negative 0.0359, D value negative 0.0027. Then the value we enter in this formula. Ln in bracket R I T equal A plus B ln T plus C ln T2 plus D ln T3. Okay. And for ln 5 I30, we get 4.7361, and the value for 5 I30 same 114 mm per hour, 5 P30, and we get 57 millimeters. For ln 5 I60, and we get 4.3988. 5 I60 we get 81.4 mm per hour. 5 P60 we get 81.4 mm. Then we calculate value of FD for equation 13.3 using this table 13.3. Product of FD value from our TC value is 79 minutes, but because it's larger than 30, and we using FD value 0.00, and we enter in this formula, and we get 5 I79 equal 43.3 mm per hour. Okay, last, determine runoff coefficient using the design chart 14.3. It's refer from our rainfall intensity I, and we get our runoff coefficient. Okay. From the table, using red line, and then from design chart 14.3, category 1, is impervious roofs, concrete city areas full and solidly built up. Refer from our I intensity value 43.3, and we get C value is 0.88, and we can determine peak flow using formula QY C times I T times area divide 360, we enter the value 0.88 times 43.3 times 30.60 and divide 360 and we get 3.2 m per second.
Assalamualaikum warahmatullahi wabarakatuh. Nama saya Nur Sara Yunis binti Sarudin 07 DKA18F 1056. Saya akan membentangkan soalan 2 untuk alternatif 2. Untuk alternatif 2 measurementnya ialah 2920 meter. Untuk overland measurement pula ialah 177 meter. Khususnya case study specification. Areanya ialah di Kepayan, Kota Kinabalu, Sabah. Housing area, total areanya 30.6 hektar. Total distance 2.60 km. Type of drainage ialah minor. Slope pula 0.5%. Length of alternative 2 ialah 2920 diikuti dengan length of overland flow 177 meter. Seterusnya, soalan pertama, determine ARI. Untuk ini, kami menggunakan 5 tahun ARI, iaitu Minor Drainage System. Seterusnya, determine TC. Kita perlu mencari TO berdasarkan daripada design chart 14.1 sebanyak 11 minit. Manakala setelah dikira TC mendapat 60 minit. Seterusnya, determine average rainfall intensity. Locationnya di Kota Kinabalu, Sabah untuk 5 tahun ARI. A sama dengan 5.6093, B sama dengan negatif 0.1034, C sama dengan negatif 0.0359 dan D sama dengan negatif 0.0027. Untuk 5P30 bernilai 57 mm, manakala 60 81.4 mm. Seterusnya kita perlu mencari nilai I untuk peak flow. Kita perlu mencari FD dahulu. FD bernilai 0.00 kerana TC sama dengan 60 minit. Seterusnya nilai I ialah 57 mm per hour. Seterusnya soalan determine run-off coefficient. From design chart 14.3 kita perlu cari nilai C iaitu 0.9 berdasarkan daripada charta tersebut. Dan yang terakhir sekali ialah determine peak flow. Untuk determine peak flow kita perlu menggunakan formula. Formulanya ialah QY sama dengan C darab I darab A bahagi 360. Setelah dikira kita mendapat 4.36 bersamaan 4.4 M3 per S.
Assalamualaikum dan salam sejahtera. My name is Dayang Nur Izzadina Sari binti Abdul Malik, 07 DKA18F1011 from DKA5B, and today I will present about my part from case study Hydraulic and Hydrology. My part in this case study is question 3, which specify the suitable open channel. First Roman, size of open channel, and the second Roman is determine flow of open channel. Okay, I will start present about my part from option 1. So from here we can see the main coefficient 0.015 and the DS we assume 0.5%, which 0.005, and B 700 millimeter, which is 0.7 meter, and D 610 millimeter, which is 0.61 meter. So for the first thing we need to do is looking for the area. The area formula is B multiplied by D, and I got 0.427 meter, and P 0.61 multiplied by 2 and plus 0.7, I got 1.92 meter, and R A over P, and I apply the formula here and I got the answer 0.222 meter, and the final is Q. The formula to find Q is here, and I apply this formula and I got the final answer here, and the conclusion of this calculation is Q calculate is bigger than Q design, so it's okay. Okay, let's move to the second option. The main coefficient still same, 0.015, and we assume S 0.5%, and B is 700, which is 0.7 meter, and D is 655 millimeter, which is 0.655 meter, and A is, as I told before, the formula to find area is BD multiplied by D, and I got the answer is 0.4585, and P I got 2.01 meter, and R, the formula for R is A over P, and I got 0.23 meter. Q, the formula is here, then I apply what I got here to this formula, and the final answer I got 0.039, and the conclusion of this calculation is Q calculate is bigger than Q design, so it's okay. Thank you.
Dharma upload 07 DKA5B I will explain about questions 4. For questions 4.1, describe relationship between types of open channels and environment impact issue. My answer will based on our case study open channels, which is open rectangular channel. So as we all know, the open channels or drain system collects storms and sometimes sewage and drain it off into rivers, lakes, or agricultural irrigation canals. But sometimes people do throw garbage and solid waste into the drain, which can cause spillover and flooding. From the flooding, the foul odors from the wastewater escape to the ground and remains there for a long time, which leads to odor pollutions. From the odor pollutions, the insects and pests will attract to the foul odors and then breeds there. As we all know, mosquitoes can cause malaria and dengue, so it can cause health risk for the residents that live nearby the drain. The flat low-lying ground drains also risk of puddle building, in which children have a tendency to play in them, which can cause health risks such as pathogens. Also, grey water from laundry and solid garbage, which is deposited in open channels, pollute water and cause health hazard. In conclusion, open drains bear a high health risk because they are often used illegally for the discharge of domestic and/or industrial wastewater and solid waste. So, therefore, maintenance operations such as routine drain cleaning, reporting of defect and blockage, semi-annual inspection survey, payments for maintenance, passing of bylaws regarding of the use of the drain and enforcements of bylaws need to be carried out. Even though open drainage systems offer very simple solutions for some water conditions, they bear many risks for the public health in the environment due to risk of illegal discharge of wastewater and solid water. Therefore, if possible, they should be applied only when adequate wastewater treatment and collection system is in place and solid water management is provided. Meaning to say, rectangular open channel is got advantage and also disadvantage. The disadvantage is open channels need a solid waste management.